Hi, this is Gabe with HTP. Today we're going to be showing you a welding repair on these standards used in equestrian competitions. So basically you have two of these guys and a center bar that connects the two, and what happens is over time they get damaged. In this case it's a little more than damage, and we're going to go over that in just a second, but basically we're going to reattach the foot back onto it. So this is the foot for our standard that was broken off. We're going to go ahead and reattach it. So a couple things that we want to go over first is the reason or cause of failure on this guy. So this guy, cause of failure I would say would be LOF or lack of fusion. Essentially they just didn't get enough penetration, and we'll see it right in here. So essentially the weld is just cold and it didn't penetrate into this guy here. So all your weld is just sitting on top and essentially is being held together with hopes, dreams, and a little bit of paint. As you can see, it cracked right down the center of the weld. Opposite side, you can see there is no fusion or penetration in there. And we look here, you can actually see the outline of the edge still, which would indicate that you haven't completely penetrated in. Right in here, you can see. So essentially the weld was just above the two surfaces and barely holding it together. So now the next step would to grind down and take down this weld so that we have a clean surface, because we're not going to be able to paint or weld over paint, pardon me. We're going to have to take down this weld as well to basically get a good surface so that we can get into welding. One thing that we're going to have to do is we're going to measure the distance from the edge to our welding spot, which I've already done off camera, which was 12 inches on both sides. That will give us our center where we're going to have to go. So we're going to get to cleaning, get this material prepped, and then we'll come back to the actual joining process. Alright, today we're going to be doing our welding repair on the standards. We're going to be using the Invertig 400 in this repair. So first thing we're going to do is get on 2T right here. We want to make sure we have our AC on, so turn AC on. Frequency we're going to run 60 just because it's thicker material and I want a little more heat. As far as balance, since this is pretty dirty, I'm going to go ahead and cheat a little bit and get this down to like 68-ish. We're going to bypass all the waveforms. We're just going to use a standard set. And then as far as amperage, I'm going to set my machine to, so in this one I'm actually going to go with 330 in amperage on the 400. I'm not going to need all that, but we're going to go ahead and use it because I got it, and that way I can go ahead and heat this up pretty quick and I won't have to preheat the material. Alright, I cleaned it all off with the grinder. Next thing we're going to do, just out of good practice habits, we're going to go ahead and acetone wipe it. Make sure we get a lot of the dust off of it. So we did grind off the majority of the material. One thing that we are going to have to do is we're going to use compressed air, and the reason behind that is when I'm actually welding, I'm going to go maybe about this whole run, but given the amount of amperage we're going to be using, it will start to burn the paint, so you'll have paint on fire. So we're going to go ahead and use compressed air to try to combat that so that we don't have any issues. First off, we're going to go ahead and line with our marks that we made. So I had to grind this down. It actually broke and it pulled the material back, so it was actually sitting up. So in this section it is going to be a lot weaker, but since we're using the 400 and a lot of amps and we're going to use 1/8 inch material, it will fill it back up and we should be good. And we're still rolling. So I'm not going to actually clamp this when we're welding. And the reason being is because right now it is out of square. So we're gonna weld it back into square. So essentially we're gonna make it straight. So these two sections here are square, but as soon as I put a tack in it, it's gonna move. So you're gonna end up fighting, you know, the best clamps in the world will never keep it completely square. So we're gonna just eliminate that by welding out of square to in square. So first I'm gonna go ahead and tack it, and then we'll go over some other things. So we're gonna be using a CK18 rigid neck TIG torch water cooled. We're gonna be using this one just because we're gonna be in higher amperage, so this guy can handle the amperage we're gonna throw at it. We also are gonna be using the Edge gas lens number 7 kit that they use, and we should be good to go. 3/32 tungsten we're gonna be using. Alright, so we could see right here that we are just a hair out of square. Before we were a lot worse. Roughly about 1/8 of an inch out of square, which we're going to weld it back into square. So now we're going to check our other two sections. So now on this guy, ready? So now on this guy, it's actually leaning that way. If you look down at the bottom, we're out of square here. So when I check this side, it's going to be out of square up top. Is, as you can see up here, we're just barely 1/8. So in this case, because we want this piece to go that way, we're going to go ahead and do our weld here on this side first. And the position of welding here is going to be inside to outside because we want our material to go back that way. Oh baby, we're dead in as far as square. So our material moved this way, but only moved a hair that way. So now we're going to go to the opposite side, and we're going to weld out. So on this side, we're going to actually use a different filler rod. We're going to use Rockmount's Neptune filler rod, and their claim is that it'll go through essentially any dirty material. So as we saw on the opposite side, there was quite a bit of, you know, dirtiness in the material. So we're going to try this one out. Basically, I just built up that edge there just so that we have good coverage on both sides of the metal. Now I'm going to lay down a hot pass. So in this instance, because I don't have a welding square, which typically I would have cut off this edge here, I put it right up against the edge of the weld. Look down here at the bottom, look up here at the top. You can see essentially the same distance from here to here, from here to here, which would tell us that this bad boy is pretty square.
Yeah, I like that.
Since this guy was already cracked one time, we're going to go ahead and put some reinforcement on this backside, right here, and then call it a day. Dude, the Rockmount stuff welds better when it's dirty. So this was Gabe with HTP. We just welded with our Invertig 400 AC/DC machine, plenty capable to weld the standard that we did. We ran into a couple issues with the actual material, and that's what's going to happen when you get dirty material. Not all the time you're going to be cleaning in a nice production-based, clean table, clean material, everything goes nicely. So if we would have done a little more grinding, a little more, cleaning action with the actual torch, we would have got a lot better welds out of it, but the welds are solid, they will hold. Have no doubt that they're not going to break again. And in this case, time is money. We're trying to get them repaired and back out there for the shows. One thing personally that I found was I was using 4043, just our standard filler rod, and then I was using the Neptune filler rod from Rockmount. So one thing that I did notice right away was with the Rockmount, even though the material was less than ideal, it's still dirty, there's still crap in it. Again, this is aluminum that's sitting out in the weather. It's already been cracked, it's already been oxidized. All that was fighting us. But when I did get to use the Rockmount Neptune TIG filler rod, I had less trouble. It welded nicer, welded smoother. I didn't see all those impurities when you're going through welding and you see little floaties in the actual weld. I didn't get that with the Neptune. Personally, if I'm going to weld something that's cast, something that's been weathered, something that's repaired out in the field, whatever may be, I personally would probably go with the Rockmount, just in the case that it was easier for me to actually weld with it versus the other way. Again, this was our repair with the 400 Invertig. Awesome machine. Any questions, comments, go ahead and comment down below. You can also follow us on Instagram, check out our Facebook, like and subscribe. See you later.